Okay, we're continuing our work with solving a system of equations. These first four examples, again, are just practicing your calculator use. So we'll get these down. The first one is negative 72.16062. Next one is 25.26106. Next one is 225.5064. And the last one negative 17.67718. Okay. Critical thinking and logical reasoning. In this part of this lesson, I am not asking you to find a solution. I am giving you a problem and a partial solution, and you're supposed to tell me what's wrong. There is an error. Okay, here's my system. 6x plus 3y equals 8, and 2x plus 4y equals 9. The procedure they're using. Multiply the second equation by negative 3, and the first equation's written. Second equation, when they multiply by negative 3, they got negative 6x plus 4y equals 9, and the x is canceled. What's the mistake? Only the 2x was multiplied by negative 3. The new equation should have been, do this in a different color, negative 6x minus 12y equals negative 27. Okay. They needed to multiply the whole thing by negative 3 and not just the first term. Okay. Next problem. Our system is negative 3x plus 5y equals 6 and 6x plus 3y equals 7. The procedure is to multiply the first equation by 2. So you're multiplying this by 2. The second equation, they just copied down. So if I multiply this equation by 2, they got negative 6x plus 10y equals 6. Then the x is canceled. What is wrong? The 6 was not multiplied by 2. The new equation should be negative 6x plus 10y. So that part was correct, but the right-hand side should have been 12, not 6. Okay, in the next example, now in this example, we have x equals 4y minus 5 and 2x plus 3y equals 7. They're using substitution. They're putting 4y minus 5 in for x. And here's their procedure. 2 times 4y minus 5 equals 7. What's wrong with that? They need parentheses around 4y minus 5, and they forgot the 3y term. The new equation should be 2 times 4y minus 5 plus 3y equals 7. Okay, making connections. So I'm going to ask you to explain how you would determine that -2, 1 is a solution to this system. I'm not asking you to do it, I'm asking you to explain it. Plug in -2 for x and 1 for y in both equations, and verify that you get equal values in both equations. Okay, next one. Okay. Again, explain how you would solve the following system. Okay, so I don't have x or y by itself, so I am going to use addition, elimination, to solve. Okay, if I look at my x's, I have 3 and 6. If I look at my y's, I have 4 and 3. So the easier one is to get rid of x, because all I have to do is multiply the first equation by -2. Multiply the first equation by -2. Then add the new equation to the second equation, and the x term will cancel. Continue solving for y. Then I'm going to plug y plug my answer for y into either original equation and solve for x. Okay, again, number 3, explain. Again, I don't have x or y by itself in either equation, so I'm going to use addition, elimination to solve. Now let's figure out how we're going to do that. My x coefficients are 2 and 5. So my LCM is 10. I would have to multiply the first one by 5 and the second one by 2. My y's are -6 and 7. The LCM is 42. So I'd have to multiply the first one by 7 and the second one by 6. Since the y's already have negative or opposites, one is negative, one is positive, I'm actually going to choose that, but it wouldn't matter. As long as you explain it correctly, it doesn't matter which one you get rid of. So I'm going to multiply the first equation by 7 and the second equation by 6 to get -42y and 42y respectively. I'm going to add the new equations together to eliminate the y terms. Then I'm going to solve for x. And then finally, I'm going to plug my answer for x into either original equation and solve for y. Okay, on the last several pages, we just have problems to do. Okay, and notice in the instructions it says report your solution as an ordered pair. So once we have x equals y equals, we'll write it as an ordered pair. Okay, we will be using either substitution or elimination. Okay. If it doesn't tell you which one to use, you could get to choose. If it tells you, you have to do it the way that it asks for. Okay, so number 1, 4x minus 3y equals -5, y equals 6x plus 1. Since I have an equation, it didn't tell me, and I have an equation where I have a variable all by itself, I'm going to use substitution because it's going to be easier. So I'm going to take 6x plus 1 and I'm going to substitute it for y in the other equation because y is the same as 6x plus 1. My new equation is 4x minus 3 times 6x plus 1 equals -5. Initially it looks worse, but you notice I only have x's now. When I distribute, I get 4x minus 18x minus 3 equals -5. Combining like terms, I'll do this in blue. I get -14x minus 3 equals -5. -14x, keep this simple. -14x minus 3 equals -5. Add 3 to both sides. -14x equals -2. divide by negative 14. The negative 14's cancel. X equals 2 and 14 reduce to 1/7, and negative divided by negative is positive. I'm just double checking my work because I don't remember having a fraction example. All right. Now I have x. I'm going to plug that in to find y. I'm going to use the second equation. Y equals 6 times 1/7 plus 1. Y equals 6/7 plus 1. Well, I can write 1 as 7/7, and I have to common denominator. Y equals 13/7. So my answer would be the ordered pair x 1/7, y 13/7. Okay, I'm going to do a quick check on my calculator to see if this is right. Because like I said, I don't remember having a fraction answer. Okay, it works. All right, number 2. X equals negative 3y minus 13, and 4x minus 7y equals 43. My first equation has x all by itself, so I'm going to use substitution. I'm going to take negative 3y minus 13 and I'm going to put it in place of x. So my new equation is going to be 4 times negative 3y minus 13 minus 7y equals 43. And I will distribute. Negative 12y minus 52 minus 7y equals 43. Combine like terms. Negative 19y minus 52 equals 43. Add 52 to both sides. Negative 19y equals 95. Divide both sides by negative 19. Y equals negative 5. Now I'm going to plug that into the original equation. X equals negative 3 times y, but instead of y I'm going to put negative 5 minus 13. X equals negative times negative is positive. 15 minus 13, x equals 2. So my ordered pair solution is x is 2, y is negative 5. 2, negative 5. Okay, and number 3, x equals y, and 3x minus 2y equals 5. Well, I have x all by itself. So I'm going to put y in place of x. So my new equation is 3y minus 2y equals 5. Combine my like terms, y equals 5. Well, I plug that into x equals, instead of y, 5. Well, there wasn't much work to do on that one. My answer is 5, 5, the ordered pair 5, 5. All of these were done by substitution because we started one equation had x or y all by itself. Next example. Okay, my whiteboard froze. Okay, we'll come out and come back in.